Naive Bayes is a simple but powerful probabilistic classifier based on Bayes' theorem, with a strong naive assumption. Features are conditionally independent given the class. So what does all of that mean? Imagine you are a spam filter. You want to predict whether an email is spam or not spam, based on words like free, buy, or winner. Naive Bayes asks, given these words in the email, what is the probability this email is spam? This is where Bayes' theorem comes in. So, probability of the class given feature, so probability of it being spam given these words, it's gonna be probability of the feature given the class. So if it's spam, what's the probability that it has these words? Times probability of it being spam divided by probability of it having these words. So naive assumption, instead of calculating probability of the features given the class directly, which is difficult, so instead of calculating probability of these words given that it's a spam or not spam, naive Bayes assumes all features are independent given the class. So what does that mean? Once you know whether the email is spam or not, the presence of the word free gives you no extra information about whether buy is also in the email. In other words, if an email is spam, the probability it containing the word buy does not depend on whether free is in it. The features free and buy are conditionally independent, given that we already know the class. If we already know the class, for example, spam. Without independence, let's say you find free in an email. You now think buy is more likely to appear. That's dependence between features, but naive Bayes ignores this. With conditional independence, in naive Bayes we assume that probability that there are words free and buy, given that it's a spam email, is equal to probability of the word free given spam times probability of buy given spam, because these are independent. So they if both of them are contained, the probability is just multiply this probability and this probability. Instead of modeling how free and buy co-occur in spam emails, we treat them as separate signals. Why it's naive? In real life, spam emails include both free and buy together more often than chance. So the features are not truly independent. But naive Bayes pretends they are because it's way easier to compute. Surprisingly, the naive assumption still works very well in many tasks. So summary, features are independent given the class means once we know the email is spam or not, the presence of one word like free doesn't tell us anything about the presence of another word like buy. This simplifies math. Now it's a lot easier to calculate because we just multiply probability of this one times probability of this one because they are independent to get the total probability. But it's a simplification, and that's why we call it naive. So let's go back up. So this is this naive assumption. So we just have a product of probability for each feature given the class. So that's how we get probability of these features given the class. So this is this in our formula, this one. And then we have this final formula. The class is equal to argmax c of probability of c times our formula that we just explained. This is the heart of naive Bayes classification. Let's go step by step. Goal: we want to predict the most likely class C for a given input. X is these words. So let's say we have these words here. For example, given an email that contains certain words, is it more likely to be spam or not spam? So let's see this C, the predicted class, spam or not spam. Argmax C, choose the class C that gives the maximum value of the expression. So what does that mean? We'll see. So these three are what we just explained. Probability of the class C, probability of feature given class, and then product. So in words, for each possible class C, calculate probability of the class times this formula that we just explained. Then choose the class with the highest result. So that's the argmax. So suppose we're classifying emails as spam or not spam. Email contains the words free and buy. We compute for spam, so probability of it being spam and probability of word free being in it given class spam and this. And for not spam we do the same, but just for not spam. And we pick the class with the highest score. And your computer may not be able to represent that precision even. So we just use the log of these small numbers between, those numbers are between 0 and 1. So instead of this, so when this is a number between 0 and 1, this will be some negative number, but it's going to be whole number. This is implementation in Python. You can just take a look. It's just what we were explaining right now. So this is predict new example. And then just to run the prediction, let's say new email contains free and buy, so we have 1 and 1 for free and buy, and then we can predict if it's spam or not spam. That was it for this video. Check out my channel if you want to learn more about AI and machine learning, and see you next time.